next one, probability 1/16, you win $16. And so you're right. This ends up just being 1 plus 1 plus 1 plus 1. So in expectation, this game is worth an infinite amount of money. But now I think we get back to what you said with the money and the acorns, which is no one really wants as much money as like the large amounts of money that most of this expectation is coming from. Like, it gets very, very unlikely that you'll win, billions of dollars. But even if you did, at that point you wouldn't care as much. And so in terms of the amount of money people would actually pay to play this game, like, in theory, it's worth an infinite amount of money, but I think in practice they did a study on this and people would pay, a couple of dollars for it. Like, in terms of the things that are likely to happen, that's all it's really worth to you. This isn't really a paradox.
The time is now 4:30, and the Milburn Library will be closing in 15 minutes. If you have items to check out, please bring them to the circulation desk at this time. Thank you.
Okay.
I have items.
So this isn't really a paradox like the first one, in that we know exactly what's going on. It's just that it highlights that the way that we actually approach money is very sort of risk averse and diminishing returns for large amounts of money. And so if you had X be like your expected happiness, and then your happiness was a diminishing function of the amount of money that you get, then this would actually be worth a lot less. For any reasonable happiness function, other than just like, I'm linearly happy the more money I make, which hopefully isn't your happiness function. Okay, so I think because, the library is closing in 15 minutes, we'll move on to questions now. And any questions? Oh.
It's not exactly a question, but I'm just saying that I have a friend that knows if he flipped the coin at a certain angle, and he knows whatever it's going to be, as long as he can see if it's heads or tails.
Mm-hmm.
So that just makes the probability for him to be on infinite. 100%.
Yeah, so if your friend were allowed to do the coin flipping here, then this would be worth his life savings.
I am never going to ask Winston Wall. I'm never going to solve a dispute with Winston Wall by a coin flip. Thank you for your information.
Yes?
I have a question about that paradox.
The St. Petersburg?
Why would people just want to bet as much money as they have? Because you don't actually lose any money if you flip tails on the first flip.
Well, so we're not, when I say bet, I mean pay to play this game and then lose. So let's say like I give you $100 and then you will play this game with me and give me whatever my earnings for the game are. So I lose the $100 and I gain back as little as 2 and as many as a huge number of dollars. Yeah, that's what I mean. Sorry.
Maybe $1,000.
Yeah.
Does it have anything to do with math? You have to get
That's a great question. I actually don't know. You can look it up though. Anyone else? No? Yes?
The probability for something didn't happen to be a real number, then how do we use the function?
Sorry? If the probability for something...
Does it happen to be a real number, and then what do we do with the function?
We define it so that probability always is a real number, because it doesn't really... Like, to say that the probability is an imaginary number, you have to tell me, like, what that means in my system, because otherwise I don't know what to do with it. Like, but yeah, I can't do anything with it, so it's just sort of outside the system I've created. Anyone else? All right, well, in that case, let's thank the organizers and
Thank you, Roger. And I just want to thank everyone for coming, and I guess we'll see you next time.